Here at Edibon, we design, create, and build engineering training equipment for tomorrow's technology to the highest possible US and European standards. Edibon, 40 years of excellence. Today we'll be taking a look at the Smart Grid MPSS system. Shown here is the power supply for generation and processes. And here this section for transmission and distribution plus consumption and loads. There is availability of direct manual control locally on each module and remote. That also goes for regulation for the relay protection systems and for all distribution. Of course, this is designed and utilized with the industrial version of SCADA. The SCADA version is created here at Edibon and can be controlled remotely. Simple to manage and programmable with open protocol for the end user to integrate with any future equipment or additional software for cybersecurity research and development. And it's engineered to adapt. Here we have the system representation explaining all the details including the loads on the software. The switch interrupters also permit isolation of the power and transformers plus generations and transmissions loads. We'll see active and reactive voltage analysis and frequency synchronization. Being able to fully study the transmission line. Full analysis, ODF voltage, regulation and thus distribution remote, including changes to study the outcomes automatically from the sensor parameter management. Feeder management. Change of auto regulation toggle. Enter into any of the 3 standard applications of generation, distribution, and user or commercial loads. For each section, as we previously mentioned, take generations from brushless hydro for example. You can see the downloads like a plant to establish full control of all parameters. Let's start again with the generator management. As you can see the motor control panel, hydro or wind, gen, etc. You may also attain the control for the turbine for the control factor. Emergency stop, which there also exists a physical one per OSHA standards. The S2G1 switches us into the network, but only when it senses acceptable synchronized moments of phase frequency and voltage. Microgrid research possibilities are provided, but could also be done totally isolated while still controlled through SCADA. As we choose to enter the line and configurations, we could play with all common industrial circumstances such as inductance, resistance, and capacitance. During power transmission, we can simulate loss of one phase or other simultaneously. The effects of imbalanced lines and/or loads could be studied. Substations and true busbar experiments are also available for CSE. Now finally we have arrived at the loads which can be SCADA controlled in parallel or combination as mentioned. All parameter calibrations could be set to extreme precision for reasons of R&D. If we switch to Gen and check for reactive voltage for increments, VFD decreases 60 Hz to 50 and 41 Hz. VFC, the rest will adapt accordingly. Thank you for your time and consideration of our smart grid.